Ladies and gentlemen, welcome into Inequality Theater, where our subject for discussion is, why does your inequality sign flip if you multiply or divide by a negative number when solving an inequality expression? So I first came to know this rule back when I took Mr. Simpson's Algebra 1 class years ago. And he said, your inequality sign is going to flip from greater than to less than, or less than to greater than, if you multiply or divide by a negative number when solving an inequality expression. And I said, okay, I'll do it because I follow what you do and I believe what you say, but I never really understood why until recently. So let's look at this equation we have up here. Negative 2y is greater than 10. So to solve this, I want to get the y by itself. I want to undo it, do the opposite to it to make that happen. Negative 2 times y is multiplication, so I'm going to have to divide each side by a negative 2 to undo this. So I'll divide each side by a negative 2. Let's see, these two negative 2's are going to cancel out. I'm going to leave me with a y. 10 divided by negative 2 will leave me with a negative 5. And Mr. Simpson said, flip your sign. It's greater than now. You have to flip it to less than. And I said, yes, master, whatever you say. I hear and obey. But I have no idea why, but I'm going to do it. Well, let me show you why. Continuing on with our theme of teaching math from the concrete to the abstract, you can show your students this. Have them pick any two numbers less than 10 and make it easy on yourself. Keep them small. So I'm going to pick, let's say 4, and I'm going to pick 2. Okay, so put in an inequality sign. Let's see, 4 is bigger than 2, so I'm going to say 4 is greater than 2. I always remember the two things are pointing at the bigger number, the one thing's pointing at the smaller number. Okay, cool. So let's say in the process of solving an equation, I had to multiply both sides by negative 2. So let's do that. I'm going to multiply 2 by negative 2. I'm going to multiply 4 by negative 2. So let's see. Negative 2 times 4 is going to give me a negative 8. 2 times negative 2 is going to give me a negative 4. Okay, so which one of these jokers is bigger, negative 8 or negative 4? I like to use the number line to help me decide, because with negative numbers, the one that's closer to 0 is going to be the larger number. Students sometimes get confused because they're thinking 8's bigger than 4, which is very, very true on the positive side. But on the negative side, we've got to think about which one's closer to 0. So let's go to the number line. So negative 4 is going to be right here. I'll write that on my number line, negative 4. Negative 8 is going to be right here. I want to write that on my number line. So which one's closer to 0? Well, I can see that negative 4 is definitely closer to 0 than negative 8. So my inequality sign, let's go back up and take a look at this, showed before greater than. But I can't say that anymore because negative 4 is bigger, so I'm going to have to flip my sign, and that would then read negative 8 is less than negative 4, because it is, because negative 4 is closer to 0. So you say, okay, it works with multiplication. Great. You said it also worked with division. Let's see an example of that. Okay, well, I'm going to switch over here, and maybe we'll be cool and go under the number line. And so let's say, again, I'm going to try to pick some easy numbers here. Let's say I had a negative 6. And let's say I had a positive 4. Okay, put in an inequality sign. Let's see here. Negative 6, negative 4. Well, 4 is definitely bigger, for sure. So I'm going to say negative 6 is less than 4. Okay, so I'm going to divide each of these by a negative 2. Divide by negative 2. Going to divide this by negative 2. Let's see what we would end up with then. Okay, well, negative 6 divided by negative 2 is going to give me a positive 3. 4 divided by a negative 2 is going to give me a negative 2. Let's see, is 3 less than negative 2? And we could say, no way. If we go back to our number line, I've got my 3 here. I've got my negative 2 here. I don't really even need the number line. Any positive number is going to be bigger than any negative number, so I'm going to be in good shape. So I'm going to have to rewrite and flip my inequality sign. Instead of less than, this baby's going to become a greater than. 3 is greater than negative 2. So you can show your students this method, and show them why your inequality signs flips. It flips because your numbers change, and the number that used to be the bigger number is now the smaller number. So if they see a couple times, they'll realize and they'll remember why to flip the inequality sign instead of just following the rule. So many students, when they get all these rules, they just don't really understand why they work and how to apply them. And so when time comes to take a high school equivalency test or college placement test or whatever, they apply rules haphazardly, not really caring about consistency. They heard this, they remembered that, blah, blah, blah. But I really want students to understand why they're doing something. So show them this method, pick those two numbers under 10, multiply them and divide them by a negative number, use something that's divisible by 2, and they can see for themselves why the inequality sign flips. So the mystery is solved. Man, I'll be able to sleep at night now knowing the mystery of why the inequality sign flips when we multiply or divide by a negative number is true. So work with this with your students. Show them. Just don't have them take it on faith, and they'll understand this rule a whole heck of a lot better.